继续啊。
先把知道这些东西放下。
Eco-friendly non-plastic solution is able to deal with food safety issues.
We separate our research into 4 parts. The first part is to make non-plastic wrap. After we find out the best ratio of key ingredients, we define our eco-friendly non-plastic wrap. After that, we test its property and its practical value to show that our eco-friendly non-plastic wrap can solve the environmental problem and food safety problem. First, we make non-plastic wrap. At first, we thought of glutinous rice, which is Chinese traditional ingredients to make eatable membrane. But as you can see, glutinous rice film is easy to break, and it didn't have the flexibility to be plastic wrap. So we wanted to improve it. We thought of another procedure of making bioplastic, which use glycerin and acetic acid to improve the cornstarch membrane. So we want to use glycerin and acetic acid to improve our glutinous rice film. We can see that the improved one has better flexibility, but it has poor transparency. So we thought of another ingredient, which is alginate. We thought that it can be used to make non-plastic straw, so it should be used to make non-plastic membrane. We faced a lot of difficulties, so we invent a new procedure to make our membrane. First, we fix the thickness of the paste to 1 millimeter high, and we spray calcium chloride solution on the top of the surface. And after we remove the increased pad, we use hot air dryer to dry the paste into the membrane. We can see that alginate membrane has better transparency, but it still faces the problem of lack of flexibility. So we still use glycerin and acetic acid to improve our alginate membrane. We can see that the improved one started to have the flexibility to be a plastic wrap. So how did glycerin and acetic acid impact on the membrane property? First, we want to discuss the effect of glycerin on the paste viscosity. We can see that it didn't show an obvious trend. After we make it to a membrane, as the glycerin concentration increased, the membrane become more uneven. So we choose the one with 2 grams of glycerin to be the best one because it is the most even one and it has better transparency and adhesion to the plastic. Then we started to discuss the effect of acetic acid on paste viscosity. As the concentration of acetic acid increased, the paste viscosity increased as well, and we make it into the membrane. The acetic acid improved the strength of the membrane. So after we add more acetic acid in the membrane becomes stronger. We discuss whether acetic acid and glycerin influence on paste viscosity and membrane. We set 2 grams glycerin as a fixed parameter and regulated concentrations of acetic acid. As a result, the more acetic acid we added, the higher the paste viscosity was and showed an obvious increase, but the bubbles also increased. The strength of the membrane would gradually increase as well. Because the membrane added 1.5 acetic acid was much similar to commercial plastic wraps that only added 2 grams glycerin. Also, in the process, it is easier to eliminate bubbles than loss. So we decided to define the membrane added 1.5 acetic acid, 2 grams glycerin, and 2% alginate as eco-friendly non-plastic wrap. In next part, we test the physical properties test to see whether our membrane has commercial potential and compare with other plastic wraps. As a result, the velocity of our wrap was higher than commercial plastic wraps. The PE plastic wrap was common to see in the market, but the control strength of our wrap was higher than that of PE plastic wrap. Although our tensile strength of
although the tensile strength of our wrap was lower than other plastic wraps, but the stretch length among those were significantly different. According to CNS method, we did the heat resistance test. Well, the temperature equal to 130 degrees Celsius. The membrane still didn't break. Just presented obvious color difference. We could see that in third part, the physical properties test part, our membrane had reached initial market value, so we did the practical test next. Our membrane had good visual packaging and cold storage effect because that the fruit covered with it could still be seen there, and the vegetables covered with it wouldn't shrink unlike that didn't cover. We did the microwave and steaming test because in our lab there are usually meal boxes or chicken stew covered with the plastic wraps. They may release plastic fibers through heating them, but as our eco-friendly non-plastic wrap was heated, its appearance was still like the complete one and will not release plastic fibers. So we proved our eco-friendly non-plastic wrap could solve good safety problems. The eco-friendly or non-plastic wrap had good storage ability. The water content and water activity of it will gradually increase through time passing. The water activity of it were all less than 0.6, prevented the growth of microorganisms. We did the corruptibility test to see whether it was eco-friendly or not. The result was satisfied because after 21 days, our wrap could not be seen, while commercial plastic wraps will still have the complete appearance. So we proved that our wrap was an eco-friendly product. To summarize, our research successfully developed an innovative producing process. Also, our wrap could solve the food safety problems. Even more, it was an eco-friendly product. Thanks for your attention.